Oftentimes in storms, we can get snow to rain, we can get snow to sleet, snow, sleet to freezing rain. But what determines these precipitation types? So let's talk a little bit about this. First of all, when you think about the troposphere, which is where the game is played, you're looking at about 40,000 feet. So we're only going to need about 15,000 feet of that atmosphere to grow the snow and produce these different precipitation types. And sometimes you don't even need all that. But let's just start up here where the snow crystals are developing. We call this the dendritic growth region. Now, it's pretty easy to produce snow when you've got the snowflakes that are already being produced up there, and they fall down through the atmosphere all the way to the ground as snow, because the whole column itself is below 32 Fahrenheit or 0 Celsius. And so what you wind up with? This beautiful Courier and Ives postcard down here, right? That's easy. But what happens when you start introducing a warm layer? So on average, let's play with that warm layer somewhere between 5,000 and 10,000 feet. Maybe not all of it. So we've got snow. We've always got snow up there in the wintertime, usually 15,000 feet on up, okay? So here come those snow crystals rolling on down to that layer. All of a sudden, it goes above 32 degrees, starts to melt either the entire flake or a little bit of it. But once it starts to fall back into that air that's below 32, it becomes a sleet pellet. So it completely refreezes again. And you can hear the sleet. You can hear it on the rooftops. You can hear it on the street. You can hear it on your car if you're just sitting there. And sleet and snow are typically okay to drive in. But this last precipitation type, all right, so let's play again with the atmosphere. Go up to 15,000. We've got snow down through 10 on average. It melts. It's still melting all the way down to about 2,000 feet. And then on under, that air mass is just cold enough to refreeze whatever's at the surface, but it's very shallow. Now, this can vary anywhere between 200 and 2,000 feet. But the problem is you don't get a chance to refreeze that droplet. It comes down as a liquid, and whatever it hits, it turns to ice. And ice is the worst thing to drive on, especially if you're going too fast. Yeah, stuff like that can happen. So the rain keeps coming down in the freezing layer. It accumulates on everything. The rooftops, the tree limbs, and you wind up with some big problems in through here. And unfortunately, too, you've got power lines involved in many, many cases where that ice is accumulating on the power lines. Now, between the two poles, if you just take, on average, the weight of a 1/4 inch of ice adds about 500 pounds to those lines. And, yeah, that means power loss and all sorts of problems. So those are precipitation types and basically how they form. Obviously, you can get all of the same precipitation out of one storm. You can get a combination of all three.